What's going on everyone, you're back with your boy Jono for another quick math lesson. Today we're going to look at bearings and trig again, but today we're looking at extension problems where two people move from the origin and we still have to find out where they are in relation to each other. So what I want you to imagine is that two people, Abby and Bill, are having a fight, a massive fight at the origin. At the end of the fight, they storm off in different directions, but Bill really wants to make amends and he's going to run to Abby, but he doesn't know where she is. What we've got to do is tell Bill exactly how far and at what direction he needs to run in order to get back to her. So Abby's walked at 200 meters at north 35 east, and we're going to throw that in first. We do definitely need to make sure we've got our angle in there at 35, and we also know the distance is 200 meters. Bill's helped us out. He's gone directly south, and that's only 300 meters. So these are our 2 points, A and B. So the big takeaway for getting these ones right is seeing that now, even though there's two directions, Abby's gone one way, Bill's gone the other, we can still make a right angled triangle that shows us exactly the directions to get from Bill to Abby. So what we need to do is work out how far the north-south distance is away from each other, and also how far east or west are they. So we still need to just find the two vectors that will make up this total hypotenuse. So the first thing we need to do is work out how far north Abby's gone. We don't care about how far east, we just need that north direction to start off. So if we have this little triangle here, we're going to use cos because we've got cos 35, the adjacent north, and then that hypotenuse of 200. So to get north by itself, we just have to do 200 multiplied by cos 35, which is equal to 163.8 meters. We're just going to use whole numbers. So on my map, I'm just going to write 164 meters. And now we've got to find how far east did she go. This is just sine 35 is equal to east over 200. So east by itself is 200 multiplied by sine 35. This is equal to 114.71 meters, or 115 rounded up to the nearest meter. So now we've got all the information we need. We know that the total north-south distance is the 164 meters from Abby plus the 300 meters south that Bill went. So we've got 464 meters in total. And then the easterly direction is just that 114, nice and easy. The big pro tip is to draw another triangle. Show this next step, putting in our distances, because then we can just see, oh, it's just a right angle. So all I've got to do is find the direction from Bill to Abby, and then that distance, or that hypotenuse. I'm going to find the bearing first, and that's just tan theta, and that is tan theta is equal to opposite 114 divided by 463. So I've got to do the inverse of tan to find that, so just tan minus 1, and that's equal to 13.8 degrees. And that is the actual bearing because we're going from north just a little bit to the east. Then I've just got to do Pythagoras' theorem in order to find out what the distance is. So d is equal to the square root of both of these squared. So 463 squared plus 114 squared. If you just throw that in the calculator, the answer is 477. So we now have our answer. We've got our direction and we've got our distance from Bill's perspective up to Abby. This makes sense because if you just think about where he's standing, he definitely is running northeast. So 13 degrees makes sense. If you had to find out what Abby's perspective was for Bill, it would be southwest, and your answer would be a lot bigger. The big takeaway for these harder questions is we're just going to have to make multiple vectors, and drawing it out correctly is incredibly important. So we need to find out the north or south distance between two people, and also the east and west distance. And then we have to make a new right angle triangle with this information. And from there, we're just repeating the steps that you've already done. So I do know these questions seem a lot harder, and they can get even more complex if you've got Bill walking at an angle, not directly south, but the same manner applies. How far north and south, how far east and west, and then use that as the basis for our new direction and our new distance. Thanks so much for watching this lesson, and I'll see you later.